When we talk about the uniform distribution, we're talking about a continuous distribution where everything is equally likely. So when I like to do these problems, I like to think of it as a box of probability. Let me show you how that works. When this says let x have a uniform distribution from 0 to 8, find the probability, the first thing I do is I draw my box. So my box is all the same probability, so you can think of this y-axis as p of x, and it goes from 0 to 8, saying everywhere between 0 and 8 has equally likely probability of occurring. So for each of these first 4 problems, this is going to be my box. In order to find the probability, I'm going to need to shade the area that they're talking about in the probability statement. So when they say that x is less than 3, I'm going to start by figuring out about where 3 would be in my box. After I see where 3 would be, if it says less than, I shade to the left. If it says greater than, I shade to the right. Here it says less than, so I'm going to shade to the left. What I now need to do is take this picture and translate it to a probability. The way I'm going to do that is I'm going to use the denominator as the whole space of the box, and I'm going to use the numerator as the shaded space in the box. So if I take shaded over whole box, that'll tell me the probability that I land in the shaded area. So really, the probability here for the uniform, p of x, equals on top, end of shaded area, 3, or in other words, the rightmost point in the shaded area, minus start of shaded area, 0. On bottom, end of box, 8, minus start of box, 0. This becomes 3 over 8. If I put that into my calculator, it'll tell me 0.375. For number 2, it asks me what's the probability that x is more than 7. Again, I can start by drawing my box. My box still goes from 0 to 8. Here's where 7 would fall about. Because it says more, I'm shading to the right. Again, when I go to find the probability, p of x, on top I put end of shaded area, 8, minus start of shaded area, 7. On bottom I put end of shaded area, 8, or unshaded area, minus start of unshaded area, 0. 8 minus 7 gives me 1. 8 minus 0 gives me 8, so this should give me 0.125. Number 3 says x is between 2 and 4. Again, I make my empty box that goes from 0 to 8. Let's say 2's there, let's say 4's there. This would be the shaded area that I'm looking for. That means that my probability on top is the length of the shaded area, which ends at 4, starts at 2. On bottom is the length of the whole box, which ends at 8, starts at 0. This becomes 2 over 8, which is 0.25. Finally, they ask me what's the probability that x is greater than 10. This is a trick question. Here I have 0 to 8. If I were to put 10, 10 would be here outside of the box. Anything outside of the box doesn't occur. The only available possibilities are inside of the box. So because this says greater than 10, I'd be shading to the right, but none of that is inside of the box, none of that has any probability. That's why the probability of x here equals 0, because none of it counts. If instead I said, what's the probability x is less than 10? Well, in that case, I would have shaded the entire box. When you shade the entire box, it occurs with probability 1, or there's a 100% chance that it occurs. So the 2 ways that you could be asked trick questions, if they say something greater than the highest number, that's off the screen, or 0 probability. If they say something less than the lowest number, again, impossible, probability 0. But if they say something greater than a number less than the box, that includes everything. If they say something less than a number greater than the box, that would include everything. So for the most part, there's not really going to be that many trick questions. I just want you to understand how things could be asked that are a little trickier than just shading inside what's on the box. Moving on, we have a new uniform distribution in parts 5, 6, and 7. Instead of going from 0 to 8, they tell us that this box goes from negative 2 to 12. That negative is going to be particularly tricky. But really, what we need to do is the same thing we did before. Start by drawing in the box that's created. starts at -2, goes to 12. When they say probability x is greater than 0, 0 would be here, greater than means shade to the right. So, in order to find this probability, I'm going to take the shaded area. Shaded area ends at 12, starts at 0. I'm going to take the unshaded or entire box, ends at 12, starts at -2. The key is I need to remember this negative really becomes a positive. So on top, I'm going to have 12. On bottom, I'm going to have 14. If I put that into my calculator, 12 divided by 14, that gives me the probability 0.857. I'm going to call it 0.86. Again, for number 6, I'm going to start by drawing my box. It goes from -2 to 12. In this case, they say x is less than 7. So let's say 7's about here. Shade to the left for less than. So the top part of my fraction, the shaded area, ends at 7, starts at -2. The whole box ends at 12, starts at -2. On top, I'm going to get 9. On bottom, I'm going to get 14. And when I put that into my calculator, 9 divided by 14 gives me 0.64. For the final one, again, I'm going to set up my box starting at -2, going to 12. In this case, it shows me that the x value is greater than -1, but less than 5. So here's -1, here's 5. I would shade between the two of these. Again, my shaded area ends at 5, so that goes on top. It starts at -1. My whole box ends at 12, starts at -2. On top, 5 plus 1 gives me 6. On bottom, 12 plus 2 gives me 14. And finally, in my calculator, when I do 6 divided by 14, it gives me 0.43.